The second situation is that a Gaussian beam passing through a thin lens. Consider a thin lens with the focal distance f. Before the Gaussian beam passing through the thin lens, the initial Gaussian beam can be described as the following way. And as we have said, the function of the thin lens is provide the phase change. So, according to the function of thin lens, we know that for amplitude, due to the lens is very thin and lossless, so the amplitude is unchanged after passing through the thin lens. But the thin lens will provide different phase delay according to the distance between the points to the center one. And the phase delay is the L function, writing in this way. Okay, so let us see what will be the total phase delay after passing through the lens. Suppose that after passing through the lens, the phase of the Gaussian beam can also be written in this form. Compare with this turn and this turn, you see, after passing through the lens, the Gaussian beam will have a new R prime here, okay? That is, they will have a new radius of the phase front, which is represented by R prime. And the R prime, of course, is formed by the origin phase. Times the function of the thin lens times the L function. Okay, the phase after passing through the thin lens is the original phase times the contribution of the phase delay provided by the thin lens. And compare with the exponential function between these two sides, you can see that the inverse of R prime can be written as the inverse of R minus the inverse of F. Right? So, based on this result, we say that for the inverse of Q is defined as this way. So we say, after passing through the lens, the Q become Q prime And the inverse of Q prime can also be written in the same way, like this. And from this result, we know that the inverse of R prime can be replaced by the inverse of R minus the inverse of F. So, compare the inverse of Q before the length and after the length. We will say that after passing through the length, the inverse of Q prime can be written as the inverse of Q minus the inverse of F, where F is the focal distance of the scene length. Besides, by this relationship, the Q prime can also be written in as this equation. So, this is the transformation of Q for a Gaussian beam passing through a scene length.